Now I would like to invite our first guest speaker, Professor Dr. Fridoon Jawad, for his talk on basics of stem cells and exosomes. Sir is currently serving as Head of Physiology and Cell Biology and Head of Human Genetics and Molecular Biology at UHS. He has more than 30 years of experience in stem cell-based therapies. In 2008, he established his first Pakistani stem cell lab at New Hospital, Lahore. Professor Dr. Fridoon Jawad.
Assalamu alaikum. First of all, thank you, Atif Saab, for giving me this opportunity. It's a pleasure coming here. This is my first time at this institution. I know the main topic is dermatology, but I'm going to briefly introduce stem cells and exosomes. So they have a very important role in dermatology, so people can understand what they are and how they work. Basic science of these two entities. Okay. I would like to start by telling you that regenerative medicine or tissue replacement is a very important and upcoming field in medical sciences. This fact can be highlighted by the statement here: every 30 seconds, a person dies from a disease that can be treated with tissue replacement or stem cell. Over the course of our lives, we keep on losing cells. We lose our cells as a result of disease or injury. And as we know, all organs are dependent upon functioning of their cells. So over course of period when cells become less in quantity in the organs, their function is compromised. That basically is a normal, that is how we age, and also because of disease or injury. So what are the strategies cell biologists have come up with to correct this problem? So let me briefly introduce you to stem cells. There are many different types of stem cells in our body. All our organs have a niche where stem cells reside, and there are other sources from where stem cells can be obtained. Thank you. So what are the two very important So the two very important properties of stem cell is renewal. They can make more copies of themselves, and also they can differentiate into specific type of cells. So as in the beginning of this presentation, I mentioned that over the course of time, because of aging and also disease and injury, we lose cells from organs. We lose cells from our different organs. So stem cells fit fairly well in that paradigm because they can make more copies of themselves, and they can also differentiate into specific tissue cells. So now I will briefly tell you about two different types of stem cells. Primarily, they can be categorized into embryonic stem cells and adult stem cells. Embryonic stem cells are obtained from developing embryos, generally at blastula stage, from the inner cell mass. These cells, as a result of that, the embryo is destroyed. So there is an ethical dilemma attached to working with embryonic stem cells because it results in death of the embryo, and some people equate that with death of an individual. Thank you. Thank you. So the purpose of these cells is can have a more remarkable type of cell in the body. However, since they are foreign in origin, they can cause, of course, immune rejection. There are strategies around it. I'll briefly mention one of them. The plus point also is that these cells can make many copies of themselves, almost unlimited copies of themselves, in contrast with adult stem cells, which have limited ability to make more copies of themselves. See, so how we overcome the problem of immunogenicity caused by embryonic stem cells. So one of the ways you can do is you can do nuclear transfers. So you can take cells from an adult individual, and transfer the nucleus into an egg. As a result, the egg will have, when egg develops, it will have the programming of the donor nucleus. So the MHC molecules that result after the nuclear transfer will be from the donor DNA, not the recipient, original DNA. So that is one of the ways you can do it. There are other ways you can do it. Now, let me talk about adult stem cells, because these cells are more important in therapeutics and in medicine. They are harvested from different niches. As I mentioned, all organs in our body have limited supply or limited quantity of stem cells in them. You may have noticed that our skin, when we get cut or bruises, regenerates. There are two very good sources of adult stem cells which have higher amounts of stem cells. As we know, bone marrow is one of them, and the other is the adipose tissue. Those two sources, people have been using stem cells from these two sources for much longer than any other source. So there is no ethical dilemma attached to use of adult stem cells, since we are not harming any embryo or any person. They're taken generally from one person and administered to the same person, resulting in autologous cell transfer. The minus points are that they have limited ability to make more copies of themselves, and secondly, they have a limited ability to transform into different type of cells. So these are the two limitations of using adult stem cells. Another plus point for using autologous stem cells is that they will not cause immune rejection. Another type of cell which is coming up in research and also in therapeutics is induced pluripotent stem cells. So the idea behind it is retrodifferentiation. As you know, life starts with a single egg, fertilized egg, and we get all our cells from that single egg. So that egg has a potential to make many copies of itself, those cells, and also make different type of cells. So how about if we take a differentiated cell and make it into a stem cell having those two important properties in the beginning, making ability to make many copies of itself and also differentiate into different type of cells. So this can be achieved if we take cells, for example fibroblasts, and treat them with either you can do genetic manipulation, or you can treat them with specific signaling molecules to reprogram the cell. Generally, there are four components, four genes that cause cells to retrodifferentiate into a stem cell-like state. I have mentioned here FOX4, SOX2, CREC, and KIC4. So they give these cells, if you get these cells to express these four genes, they will become stem cell-like in their nature, and then you can use these cells therapeutically also. If you are using the genetic manipulation, then there is of course always concern that these cells may go through neoplastic transformations. So currently these cells are not being used in therapeutics, however they have a great potential to cure many diseases. Another type of adult stem cell that is also being used in therapeutics currently in Pakistan and in many other places around the world are the stem cells derived from umbilical cord. These cells have one of the highest potencies in terms of replication capacity, making more copies of themselves and differentiating into different type of cells in the body when we are talking about adult stem cells. So these cells are sort of between embryonic stem cells and adult stem cells. Of course, these cells, when they are used, generally they are allogenic, meaning they are foreign in origin. However, the plus point of using stem cells from umbilical cord is that they express very low amounts of HLA, human leukocyte antigen, or MHC1 and 2. So they do not cause immune rejection. They have been used in to treat many different diseases, neurological diseases, and also people are using them for aesthetic purposes. If there are any questions, please feel free to ask even during the presentation. I'll be happy to answer them. However, most people are familiar with the stem cells which are isolated from adipose tissue. They are the most widely used stem cells in Pakistan at least, and also globally also. So the way you do it is generally that the clinician uses a cannula to extract subcutaneous fat either from the tummy or thigh, wherever they feel appropriate. So it is minimally invasive. So the fat is collected in a syringe and then it is taken to the lab. There it is treated with different enzymes and cells are liberated from the tissue, and specifically the mesenchymal stem cells or non-adipose cells are collected through different centrifugation procedures. However, the amount of cells and the type of different cells that are present in adipose tissue drive stromal vascular fraction gives it an edge and also certain setbacks. For example, if you look at this slide, so about 200,000, 100 to 200,000 cells per ml of fat, okay, roughly. So if you're talking about 100 ml fat, so what you have is about 10 million. And out of that 10 million, only 10% are adipose-derived stem cells. So the quantity is very low. You get a very low quantity of stem cells, mesenchymal stem cells, when you're using fat. The edge here is that you also have many different types of cells, endothelial cells, pericytes, which are very important. They have a very important role in angiogenesis. So if you're treating a disease that requires angiogenic activity, these cells have an edge over umbilical cord-derived cells. So you have to decide what type of stem cell therapy is ideally suited for your patient. For example, if we're talking about neurological diseases, umbilical cord-derived mesenchymal stem cells will have greater edge, because when we're doing umbilical cord stem cell therapy, we are talking about 1 million cells per kg of body weight, which translates to roughly 100 million stem cells per patient. You don't get that number with adipose tissue. You will need a lot of adipose tissue to get that number. So another question I generally get, generally the questions I get from patients when they're during consultation is, okay, so what is the probability we will improve? How long it will take to see that improvement, and how long the improvement will last? Okay, so these are generally the 3 questions I get from patients. So I will answer those sequentially. See, there are 3 main factors that determine the outcome of stem cell therapy. Okay, so it is the age of patient, because remember that as we are getting older, so are our cells. So the older stem cells, the older they are, the less ability they have to make more copies of stem cells. Remember the first 2 rules we talked about, cells have to make many copies of themselves and also differentiate into different types of cells. So we have that ability to make more copies is compromised as you get older. So age of the patient. Disease. Just think about it. Let's talk about an example, osteoarthritis. So if someone has been suffering from disease that is for 10 years, that means that cartilage is severely damaged, and you will need greater number of cells, you will need multiple sessions to recover or regenerate cartilage. So age of the patient. Okay. Number 3 is the severity of disease. So if we are talking about, say for example, spinal cord injury, if the spinal cord injury is minimal, of course you will get better results. If the spinal cord injury is more severe, then it will take longer. It will take more sessions of stem cell therapy to get to a specific level. So these 3 factors primarily determine how a how much recovery a patient is going to get. I'm also going to talk briefly about exosomes also later in the lecture, but I think at this stage I would like to mention that very popular therapy is PRP is a very popular therapy. Okay? So, if you think about it, if you're getting using PRP from an older person, your PRP is also very old. So, what I have been doing recently is reinforcing PRP therapy with exosomes and certain growth factors. That gives patient fairly good results, and they're sort of in between regular PRP and stem cell therapy. So if patients are non-reporting because stem cell therapy is fairly expensive, and especially in aesthetics and dermatology, you don't want to go straight to the stem cell. Most people are comfortable with PRP or exosome therapy. So exosome therapy on its own does not produce those results. If you use PRP in combination with exosomes and growth factors, your results are far better. I have done that several times, and I'm fairly confident about what I'm saying. So now coming to the clinical aspect of this. So what do we do when we get a patient who is interested in stem cell therapeutics? First of all, you have to get the case history. And you have to be realistic, and you have to you don't have to, just because you want to get a patient, you never mislead the patient. Just tell them how it is, what are the probabilities based on literature, chances of their improvement, and how much improvement a patient can expect. Okay? So first at the case initiation, we get all the information from the patient, how long, when was the disease onset, how severe the disease is. We look at the lab results, we look at the radiological results from the radiological examination, and we initiate that case. So, I will like to say that once we have all the information, generally it is stem cell scientists and the clinician, we sit down together and we design a therapy specific for that person. Okay? So if one type of therapeutic works for one patient, it won't necessarily produce the same results in another patient. So we have different tools that we can use for the patients, as I mentioned, stem cells, adipose-derived stem cells, mesenchymal, umbilical cord-derived mesenchymal stem cells, and you can also, in conjunction with these type of cells, you can use exosomes, you can use PRP, you can use different growth factors. So whatever therapy works the best in that particular case, we customize it for that particular patient. So it is not uniform that if something is working well in one patient or one type of patient, it is going to produce the same results. So it's a combined effort of a cell biologist or regenerative medicine specialist and a clinician. So now I would like to share some of the results. So I know this video is a little old, but the problem is that most patients, especially who come for therapeutic aesthetic purposes, they do not like to have them photograph or make videos of them themselves. So I've been doing stem cell therapeutics at Ramadan Hospital. They recently created a new So this guy had CKD, chronic kidney disease.
एक सेकंड
तो मैंने कोई आगे इनमें सबसे मरीजों के दर्जा अभी स्टेम सेल सेंटर के सफर एक नजर काफी
कोई पे कंसल्ट किया मेरी टेस्ट हुई पोस्ट हुई उन्होंने कहा कि आप दिस कैंडिडेट स्टेम से उसको आप उसको लेके चल सकते हैं 4 टाइम्स मीटिंग हुई और मैं आपको बहुत एनर्जेटिक बेटर फील कर रहा हूँ ट्रेनिंग हुई देखो नॉर्मल में आ गए पहले ही 10 बार इस टाइम में आप जरूर कंसल्ट करें कैंसर जो है वाला वाला नहीं इसमें बहुत सी चीज़ों का क्यों रखा
मुझे 10 साल पहले हमारे दोस्तों के साथ रहते देखा आपको देख दिया उसमें इसका तमाम सर्जर मंजूर हो गया तो इसके बाद मैंने गुजरात से सीधा हॉस्पिटल को पता चला और हम यहाँ आए और यहाँ आ गए मैं सेंटर से अपना डॉक्टर आना शुरू अब मैं कोई सी स्पोर्ट में ऊपर खुद बैठ सकता पहले तो बिल्कुल नहीं बैठ सकता था मुझे काफी ज्यादा परिस्थिति मुझे इधर इंशाल्लाह बहुत ठीक हो गया
मेरे बेटे का नाम है एक्सोसोम्स में जब 9 साल के बाद बैठना उन्होंने शुरू किया वो मेरे चेकअप वगैरह करवाने से शुरू कर पहले तो मेरा रुचि उपाध्याय से और वो है ना हम ये काम करते हैं और ये ना बाथरूम जा सकता था अभी ये बोलने कुछ बस लगे हमने हिमाचल इसको बहुत ज़्यादा कर दिया मसला हम ही क्या हमारे कैंडिडेट जितने रेटिंग है ना ये जाता है तो हमको काफ़ी ज़्यादा इसमें और दुनिया आगे से बेहतर उनको लगे और ये ना
Okay, ठीक है, that's good. Slides. So these are actually, I'm sorry, little older videos, but anyways, I have done hundreds of procedures, stem cell therapy procedures, and alhamdulillah, there has never ever been a case in which patient did not benefit. So there is various degrees of various grades how much patients improve, but two important things. Stem cell therapy also, even if you look at literature, has not caused any adverse effects. And generally, if there is improvement, and it is of various degrees depending upon those 3 factors that I mentioned early on. So this is another patient, autoimmune diseases. In autoimmune diseases, stem cells have a very important role, very potent role. They can turn the autoimmune disease, the immune reaction, they can make it much milder or turn it off. So it does not just apply to this particular disease. Many other diseases have shown this result also. Diseases I have treated, you have seen a couple of patients. Aesthetic procedures I have done mostly with Dr. Bushra. She is going to talk about hers, and Dr. Uzala, here, alopecia. So I'm sure they'll discuss those results with you. Erectile dysfunction, premature ovarian failure, neurological diseases, osteoarthritis, so on and so forth. Many of them, okay? So, this, Dr. Bushra told me you have to say something about exosomes too. Okay, so generally all our cells are secreting small packets and bundles in our body. You may be surprised to hear that 1 ml of our blood contains about 1 billion exosomes in a normal person, okay? So people are using exosomes as a therapeutic agent. So you already have a billion exosomes per ml of blood. So if you calculate on it, so it probably comes to trillions of them. So why do we want to use exosomes? We can discuss that. So generally what happens is that, see, the exosomes, they come off from our cells. So the cells that are producing exosomes, if they are getting old, so their exosomes are going to have much more limited potency, regenerative potency. So that is why people thought that if exosomes are used therapeutically from cells which have greater potency, they will have beneficial effects. And they do, but I think that they're a little overhyped. I think most of you have used exosomes, and I think results are very good. Let me say that. So if you cannot use the cells For example, if you cannot use umbilical cord stem cells because of various reasons, if they're too expensive or people are concerned about getting cells, foreign cells in their body, you can use the exosomes that are produced by these cells, which will have greater regenerative ability than the exosomes present in patient's own body. Okay? So let me say a few more things about them. So basically the process is that, there is endocytosis, membrane is finished off from cytoplasmic membrane, it vegetates, it forms early endosome, and then it turns into late endosome, and late endosome that matures into multivesicular body. Not shown here, but there is heavy traffic exchange of parcels, vesicles between Golgi apparatus and multivesicular body. So ultimately these multivesicular bodies, they mature because they have many small vesicles in them. Ultimately when they fuse with the plasma membrane, they will release their cargo, which are the exosomes. Generally they range from 30 nanometer to about 140 nanometer. Average size of exosome is about 100 nanometers. Okay? So exosomes are distinct from ectosomes. If you have heard about those, ectosomes are pinching of the plasma membrane, and it is pinching outwards. Those vesicles are generally smaller than exosomes. I've already mentioned about 1 billion per ml in the blood. So why do people get variable results when they're using exosomes? Okay. So it depends upon the source of the cell, the source of the exosome, what type of cell produced it. Generally, I was told that people are using exosomes derived from adipose-derived mesenchymal stem cells. They will have far lesser ability to therapeutic ability. Also depends upon how the exosomes are isolated. Whether there was an ultracentrifugation method or kit method, both methods have their pluses and minuses. Ultracentrifugation, generally you lose, disrupts or ruptures exosomes, but generally the yield is higher, but you do not have a control on through ultracentrifugation process that you're getting a relatively purer population of exosomes. Okay, so you'll get bigger particles also that fall in that category. The second, the other factor is whether you are using natural exosomes or you are using engineered exosomes. You can engineer exosomes, you can put specific material in an exosome and program it that it goes and hits a specific target organ or type of tissue to cause an effect there. So I'm just going to leave exosomes at that and move on to, okay. This is just some statistics that I got from the net. How big of a market therapeutics is, regenerative medicine therapeutics is. So this article says about how much? Say 10.56 billion US dollars per year, and it's expected. This was in so 21 to I think it was 2021. So anyways, it's a very expanding market, and this one calculated it to about 6.1 billion by 2028. I think these are very conservative estimates. We already, many patients I get are coming from European countries and also Benelux. So because these procedures are very, very expensive there, so if you market yourself right and you convince your patient through providing proper education and reference material, if they're convinced, they will get stem cell therapy. Okay, so as you all know, there is a lot of quackery. People are calling PRP stem cells, and they're using different, I've been told that people are using machines. They claim that you put fat at one end and you get stem cells at the other end. Some people are claiming that they're importing stem cells from foreign sources. However, we have to be very honest with our patient. We have to provide education to our patient, tell them how it is, what to expect, and give them the choice whether they want to go ahead with stem cell therapy or not. But you have to give them all the right information with evidence and which is literature, and let the patient decide what is best for them. So so I'll give you an example. For example, osteoarthritis, the latest given, I'll urge audience to look at this. This is a meta-analysis of many different institutions and different clinical facilities have treated osteoarthritis with stem cells. Generally, information like that convinces patients to helps them decide whether they should go for stem cell therapeutics or not. So I have also provided references. If someone wants to look at specific information, they can. Well, that brings us to the end of this lecture. So